Okay, so we're writing merge sort, correct? And we're sorting integers. All right, so we wrote the algorithm. Well, we went through the algorithm for it last time. I showed you the random class for creating an array filled up with random values. We talked about recursion a little bit. So let's, well, let me get rid of, so let's do 20 integers here. We'll fill it up, we'll print it out, get rid of a lot of this extra junk. So we have, so let's get rid of factorial. We'll keep our print array for testing because we're going to need to print out stuff, and let's just dump all the rest of this. Oh my gosh, it's not going very quickly. Think about all that gold we just deleted. 100 lines of code. All right, so let's make sure we have 20 random integers as a starting point here. So there's our 20 random integers. All right. Now, for merge sort, we probably want to have, well, merge sort needs to know about a couple different things, right? We need to know the array we're sorting, and then the portion of the array that we're currently interested in. Make sense? Okay, so the beginning and ending of that. So when we have our initial merge sort, so we'll say static void merge sort, this guy is going to take in, we'll take in an integer array named AR, and then we'll take in a begin, and we'll take in an end, like that. All right, now we know that we don't have to do anything special if a array is trivially sorted. What does it mean for an array to be trivially sorted? Or the portion of the array that we're looking at to be trivially sorted? It means it's a one list, correct? Okay, so if begin and end are the same, we don't have anything to do. So we only need to do stuff if they're not the same. All right, so if begin is not equal to end, let's do some stuff. All right, now if we go back here to our algorithm, we were keeping track of the beginning of the first half and the end of the first half, the beginning of the second half, the end of the second half, and then we also need to know where the middle is, all right, because those pieces are going to be important for calling merge sort recursively. That makes sense? Okay. So we're going to have five variables. So int begin 1, int end 1, int begin 2, int end 2, and then int middle. All right. So we want to start filling these guys out to give us values for these. So begin 1 is going to be equal to begin, right? This guy that was passed in. So it's going to be the first portion of the array that we're looking for. Similarly, end 2 is going to be equal to end. All right. Now, middle, we're going to go ahead and calculate middle first. All right. So you're late. Look at all these late people. They didn't bring me food, no beverages, no offerings of any kind. Yeah, I did have a goat offering the other day. It's true. Didn't he steal my soda last week? Was that last week or 2 weeks ago? 2 weeks ago. Man, I hate that kid.
I got something for you, but I left it in the car.
Is it low carb?
I left it in the car.
But is it low carb anyways? It is low carb. Sometimes students will bring me like regular soda and I can't drink it. All right. So we're going to calculate middle. Middle is high plus low divided by 2. Okay, we looked at that last time. So that's going to be end plus begin divided by 2. That'll calculate our middle. Now, it doesn't matter whether that's on the, for an odd number of buckets, that doesn't matter if it's on the short side or the long side for whatever the left half is going to be, as long as we're always calculating it the same way. All right, so we can't randomize how we're calculating middle. So middle is going to equal end plus begin divided by 2. And that's going to be integer division, so you're never going to have a number like 3.4 or something like that. It'll always be a truncated value. All right, so now middle can either, well, so now we can make a decision. Again, this has to be consistent. End 1 can either be middle minus 1, or it can be middle. We can choose, as long as begin 2 is the other one, right? All right, so why don't we go ahead and we'll say end 1 is equal to middle, and we'll correct our spelling for begin 2. Begin 2 is either middle plus 1, or we can say end 1 plus 1, either one of those. That makes sense? All right, so now we have all these values that allow us to think about what's the center point of our, well, we know where the left half of the first, we know where the beginning of the left half of our list is. We know where the end of the left half of our list is. We know where the beginning of the right half of our list is, and where the end of the right half of our list is. And we know where the middle is. And the middle was just something we used to calculate begin and end, correct? All right, so after we do that, what do? Well, we call merge sort, right? Okay, well, so we'll go ahead and we'll call driver dot merge sort, passing it the same array, but passing this guy begin 1, end 1. So that's going to be passing him the left half, correct? We're passing the whole array. We're just saying focus on the left half. Then we're calling same array, begin 2, end 2. So that's the right half. So call merge sort on the left half, call merge sort on the right half. And each of those guys is going to be a new copy of merge sort here. All right, now, after we emerge, when we're here, what do we know? We know that the left half is sorted in and of itself, and we know that the right half is sorted in and of itself. So we need to go ahead and perform our merge step, all right, where we put the two sides together. Make sense? All right, so when we're here, we know that the left half is sorted. Put that in its own comment. That the right half is sorted. Now we merge. To merge, we need a temporary array, correct? We need a landing zone that is the same length as end minus, let's see, what would be end minus begin. Yep, number of buckets. All right, so we're going to create an integer array called temp, and this guy is going to be equal to a new integer array of size end minus begin. So if we had a 5-bucket array and begin was 0 and end was 5, well, actually end would be 4. So it should be 4 minus 0 plus 1. So we're going to add 1 to it to get us the right size. That's if you have end being the last legal bucket. If you have end being 1 beyond the last legal bucket, then it would just be end minus begin. So we'll go ahead and use end as the last legal bucket. So this is end minus begin plus 1.
So you don't say begin 1 minus end?
Begin 1 minus... Well, these guys were defined in terms of these guys. So end 2 is end. Begin 1 is begin. Right? Those are the same values. So we created these variables here to make it easy for us to call that, as opposed to these two calls would have looked kind of scary if we had all sorts of math crap in here, right? So we handled those inside of variables beforehand so that when we called it, it was pretty clean. So you could say begin 1 and end 2 here. They're the same values. They hold the same thing. So this is giving us a empty array that we're going to use to put our values into as we're merging, right? And then after we finish the merging, we're going to copy everything from this array back into the original array. Between positions, begin and end in the original array. All right, so now we're going to need a couple of variables. When we did our merge step, we talked about having keeping track of where the beginning of this guy was and where the beginning of this guy was. So we already have our pointers for begin 1 and begin 2, correct? So we know where the beginning of those lists are. Those are the values that we're going to be comparing. And we're going to keep going as long as we haven't gone off of either end 1 or off of end 2, right? Beyond that. All right, so we know how many times we're going to have to merge, right? We know how many times we're going to have, how many comparisons we're going to make. We're going to make temp.length number of comparisons. We're not sure which of the two values we're going to grab. Are we going to grab the guy from the left half or the guy from the right half next? Who's the next winner? But we know we're going to grab temp.length number of guys. All right. So let's just go ahead and write a loop here for int I is equal to 0, I is less than temp.length, I plus plus. So temp.length, that's the number of buckets in temp, which is end minus begin plus 1. So if we had end minus begin, so let's assume we have a 5-bucket array, and it's our very first call to merge sort. We would pass in begin is 0, and we would pass in end is the last legal bucket, which is 4. So 4 minus 0 is 4, but we actually have 5 things that we need to account for. So we need to add the 1 to it. That's because we're choosing to say end is the last legal place, as opposed to 1 beyond it. So again, that's a decision. Since we're choosing that end is the last place in the array, but it's actually a real place as opposed to an illegal position, then we'll have to add 1 to it to give us a big enough bucket. All right, so this is the number of comparisons we're going to do. And we happen to know that we're going to have enough numbers to compare. What we're going to change here is begin 1 and begin 2. So we'll have begin 1 and begin 2 kind of move down their lists, depending on who's the winner. All right, but we know that we'll be able to do it the correct number of times because our array was built to be the perfect size for this. So the first thing we're going to ask is we're going to ask if begin 1 is illegal. All right, so that means if begin 1 is greater than end 1, that means that guy's already off the end of the list, his half. Okay, remember last time we were talking about which should win, this guy or an illegal position? All right, so let's handle the case where we have the left half, we've already run out of values, in which case we just pick the guy from the right half. So if begin 1 is greater than end 1, so if we've already placed all the stuff from the left half, then we'll go ahead and say temp at bucket I gets AR at begin 2. So we'll copy into temp at the current position whatever is in our array right now at bucket begin 2. Else if begin 2 is greater than end 2, that is, we've already placed the stuff in the right half. By default, the winner is whoever's next on the left. So temp at bucket I is equal to AR at begin 1. Else, if the left half is done, right half wins by default. If the right half is done, left half wins by default. Otherwise, we have a legitimate competition. So we need to ask the question, which is the smaller value, right? So else, if AR at bucket begin 1 is less than AR at bucket begin 2, we are missing a couple things here. So we'll do our increments here in a second. Then what are we going to do? We're going to say temp at bucket I is equal to AR at begin 1. Otherwise, temp at bucket I is equal to AR at bucket begin 2. Whenever we place begin 2, we need to make sure we increment begin 2. Whenever we place begin 1, we need to make sure we increment begin 1. Because we want that guy to keep hobbling down the list, right? So now, when we get right here, after this for loop is done, we know we've done all the comparisons. Okay, we've done all the comparisons, and inside of temp are all the values that are between begin and end in AR in order. So now we need to copy them back in. That make sense? So what I'm going to do here is we're going to say int pos is equal to 0 to keep track of where we are inside of AR. Well, actually inside of temp. Then I'm going to create a loop that's going to go through all the values between begin and end inclusively, including end. So I'll say for int I is equal to 0, it's equal to begin. I is less than or equal to end I plus plus. So this is going to take I on a voyage between bucket begin and bucket end, including bucket end, inside of AR. And what we're going to do is we're going to replace AR at bucket I with temp at bucket pos, overwriting AR in that little section with the stuff we currently have stored inside of temp. So we'll say AR at bucket I gets the value of temp at bucket pos, and then make sure you increment pos. So pos is going to walk down. It's going to be bucket 0, then bucket 1, then bucket 2, then bucket 3 through temp, where I is going to be wherever begin and end are in AR. Those are the same length things, but temp is always 0 to its length minus 1, whereas begin and end might not necessarily be at bucket 0 right now. We might be dealing with the right half of a list somewhere. So that might be, bucket 7 to bucket 13 or something like that. Okay? Yeah, this is just an integer. I just created a variable named pos of type integer, and I started it at 0. And that guy he's going to be running through all the values in temp. So I use pos to keep track of where I am in temp. Okay, so for example, if begin was 7, what I'm saying is copy AR at bucket 7 into AR at bucket 7, temp at bucket 0. AR at bucket 8, temp at bucket 1. AR at bucket 9, temp at bucket 2. This keeps going up by 1 each time, but I keeps going up by 1 each time. The difference is pos definitely started at 0 because we know that's where temp starts. But I started off at begin because that's the section of AR we're interested in. We could have flipped those two around. We could have decided that we were going to use I to keep track of where we were in temp and use pos to keep track of where we were in AR. Didn't matter. We just need two different counters, one that keeps track of where we are here and one that keeps track of where we are here. Those might not necessarily be equal to each other. Make sense? So again, this just goes back to the whole idea of how do humans solve problems. We use our memory, we ask questions, we use repetition. So we're remembering lots of different things here. We had to keep track of all this crap so we can make the right merge sort calls. And down here, it gets a little, really the merge step is a pretty simple step once you get past the idea of keeping track of all these numbers that are changing as we're walking down the list, right? So that's kind of why I indicated a lot of times you'll see in merge sort implementations, I'm sure when you were doing some of your Google searches, you would see the call to merge sort would look a little bit more complex than that because they were doing all the math we did up here in here. So you would see these kind of scary calls to merge sort that were, n plus begin divided by 2 plus 1 would be, what would be right there. That kind of stuff, wherein, we did the math first inside of variables, and who cares? So we have a couple extra variables. And then we have nice clean variables to use to pass in there. Similarly, we're doing the exact same thing down here. We used begin 1 and begin 2, which by default pointed to the beginning of our two lists. And we used those guys to traverse down the array. Finally, what are we doing here? We are copying values from temp back into AR. Because temp actually holds the sorted values between begin and end. So now we're overwriting AR with those sorted values. And that should be it. So we have our unsorted array here. And actually here, there's another version of nextInt which will give you only positive numbers. So there's a version that takes in an integer. So this will give me numbers between 0 and 99. 0 and 100 exclusive, 0 and 99 inclusive. So our values will look a little prettier here. We'll be able to know they're in order a little easier, okay? Because all those huge negative numbers and stuff get a little bit unwieldy. All right, then we'll go ahead and we'll call merge sort, passing it our array, passing it begin, which is 0, and passing it end, which is the last legal bucket in our array, which is AR.length minus 1. And then we'll print our array again. Here, just so we know where it began. Since I don't know where it began and ended, we'll just print the second one. 1, 9, 17, blah, 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 blah. So that's merge sort. Make sense? All right. So what didn't make sense what we did there? So merge sort, well, actually here, I'll ask you the question. Why do you think I chose merge sort as the next homework assignment? Besides obviously wanting to torture you. What was my end goal with merge sort? Obviously we're learning about recursion. What was our previous assignment? Previous assignment was the process expression one, right? Lots of moving parts, right? So process expression had a whole bunch of like little tiny things. Would you agree that what we just did here conceptually was more complex than any individual little piece of process expression? But process expression as a whole felt like a bigger problem, correct? Okay. This one was a smaller problem, but had an algorithmic complexity to it. So it was intimidating in a different way, right? The amount of code we wrote here, and keep in mind that I wrote a lot of comments and crap like that in here to explain what we were doing. The amount of code we wrote here for merge sort was not that much. I mean, that's merge sort right there. We can almost fit it all on the screen with this giant font on, right? So there's not that much code there. But the code that we have there is very, very specific, right? All right. So one of the reasons I picked merge sort as kind of the next assignment to go back up this almost epic feeling assignment that you're like, well, I know exactly what I'm trying to do, but I can't do it. This one is, I almost know exactly what I'm supposed to be doing, and the solution isn't so much code, but you're kind of lost in the wilderness. That kind of makes some sense? Everything about these assignments is all about making you suffer, but for two different reasons. One is for my enjoyment, obviously, okay? But the other is just like when a coach takes their soccer team out and makes them practice. Okay? It's not fun yet, but you have to work hard in order for it to eventually become fun. You know, this hell that you go through on these assignments is a very important part to actually becoming good at programming and finding it fun. Okay, so, you know, you just watched me solve it while I was teaching it in 25 minutes, 20 minutes, something like that. Okay, so this was not a complex problem for a programmer. But when you're beginning new to it, it's difficult, right? All right, and it's also why I like solving it in class, so you kind of see it's possible. It's no different than if, you know, you're a tennis fan or something like that, and you go out and watch Roger Federer play, and he makes it look so easy. Right? It's like, well, I could hit a forehand like that. I always find that funny when you're watching sports. The fans always think they know better, right? It's like, why didn't you just do that? Or why did you just do, oh, you think you could do better? I don't think you could do better. See, I'm like the worst. Well, I say I'm the worst. I'm pretty good at golf, so I couldn't do better than the pros, but I could do close to what the pros can do. But I always find it like, well, why didn't he hit this? Why didn't he hit that? You know, because like, well, you could make the shot, but the reality is these guys are playing for $1.5 million, and playing it safe makes more sense for their pocketbook, right? So, in any case, you're supposed to still find these challenging. So, I take it everybody in here found the homework challenging to some extent. Nobody found it to be simplistic. All right, well, that's good. If you start finding the homework to be too easy, let me know. Okay, that way I can. Oh, so this one was too easy?
No.
Yeah. Oh, yeah. All right. So questions about merge sort. Good with this one for now? I'm going to throw the solution up on Slack. What class is this? Oh, it's one of my favorites, right? Yeah, there we go. It is my favorite class. Well, just I can just put merge sort. Who?
Printing Bob that one. I think he did that today.
Yeah, that's just my print array thing for testing.
Oh.
I just left it in there. So this is, you can copy and paste this whole thing and it'll be a full working solution. All right, so let's see. We've talked about arrays. Okay, so let's talk about two-dimensional arrays. That could be good. Actually, let me show you something else first before we get into that, just as a modification here. So what we've written here so far is the ability to sort integers. Now, we could also make this work for characters. Characters are numeric types, right, because they're Unicode values. This would also work for doubles. It wouldn't require a whole lot of modification to make it work for those things. But what if I wanted to compare strings? Okay, well, first of all, I need to have the ability to generate a random string. All right, so that's going to be a fun little function, right? Let's write a random string generator. Should that be a quiz question? No. Too easy, probably. Let's see. So we'll go static string gen string. All right, and let's say that our strings are between, I don't know, 3 and 8 characters long. Reasonable? Yeah, I'm just coming up with a way of coming up with random strings. All right, so 3 and 8 characters long is going to be our, so the first thing we probably want to generate is a random number indicating how long our string is going to be. Okay? So, I need to generate a number between 3 and 8. That's all I'm trying to do here. How would I generate a random number between 3 and 8 based on what you know right now? We're not dealing with strings or anything. I just want a random number between 3 and 8.
It's randomly generated main function.
So you want to use this dude? All right. So we'll go ahead and we'll give ourselves one of him down here, right? All right. So we got him, and then what?
And use the other.
So I want to create my length. I want length to ultimately be a number between 3 and 8.
Done next state with maximum and minimum.
Oh, but I didn't teach you that. All you know is this guy. You know r.nextant, and you know r.nextant that has one number in it. That gives you a number between 0 and whatever you put in here minus 1. So we have two versions of r.nextant that we know about right now. We know the one that gives you the numbers between negative 2 billion and positive 2 billion. And we know the one that gives you the numbers between 0 and whatever you pass at minus 1. So given those two options,
Modulus 8 minus 3.
okay, well, tell me exactly what to type. What do you want me to type here?
Next state.
r.nextant. Okay, then what?
Modulus 8.
Mod 8 in here?
No, after the basis.
So you want me to put an 8 in here?
No, after the basis.
Okay. So you want me to do mod 8 here? Like this? All right.
And minus 3.
Minus 3?
Plus 3.
Plus 3 like that?
And we should put the basis for the after equal and after 8.
Well, the order of operation should be okay here. It'll take this number, it'll mod it by 8, and then it'll add 3 to that. So this is going to give us a number you're hoping between 0 and 7? Okay. So before we do anything else here, I'm going to just switch this to void for a moment so it'll compile. So you want to do something like that. So this will give us 20 numbers, hopefully between 0 and 8. This is exploring how modulus works. I have some negative numbers in there. Close. I mean, it certainly gave us numbers kind of in the right range-ish. Right? Right range-ish. But we had some negative ones. So let's try again. Still need a number between 3 and 8. Using only tools that we have available to us so far. Give you a starting point. So here, let's actually start it up here. What's that going to give me? 0 to 8. Okay. Go ahead and run this. We should see a bunch of 0s to 8s. Okay. So now our negative numbers are gone. Now I want numbers between 1 and 8. How do I take this as the starting point?
Put 8 as seed and add this one. Add 1, 2.
Okay, so you want me to make this an 8 now?
Yeah. And add 1, 2.
And then add 1 to the result?
Yeah, there will be 1, 2. Yeah.
Okay, this will give me 1 to 8, not 3 to 8. So now I have numbers between 1 and 8. I want numbers between 3 and 8.
So
Want to add 3 to it? All right. So now I have between 1 and 10. Oh, there's a 9. So. Still not there. We're zeroing in on it. What would that give me? That would give me 3 to 8. So if I say, give me numbers between 0 and 5, and then I add 3 to that, that's going to give me numbers between 3 and 8. Right? Okay? So here's your 3 to 8 values. All right, well, I only need one number between 3 and 8. So we'll go right there. So this variable length here is going to represent the number of characters that are going to be in our random string. Okay? Now, next thing we need to decide. Now, so let's assume that my random string is going to have 5 characters in it. In this particular, I just rolled the dice, right? Rolled the dice, and I happen to get a 5. So I need to generate a string of length 5 randomly. All right, so that means I need to go through and I need to 5 different times come up with a random character in the range of things that we're going to allow in our random string. Well, what are we going to allow in our random string?
Numbers between ASCII characters.
Okay, well, I mean, realistically, could we just pick the alphabet? And then maybe we could throw like spaces in there or question marks. You know, maybe just stick with the alphabet. Upper and lower alphabetic letters. Give us jumbled up things. Maybe we'll luck out and actually make a real word. Just by random roll of the dice. So I need to randomly pick a character between A and Z lowercase or A and Z uppercase. How would we do that? It's the next step to our problem. I just want one. I want one character chosen at random between the upper and lowercase, from the upper and lowercase alphabet. We'll even write a little function. Static char get random letter. Okay, this guy's whole job is to give me a random letter. How would we write that? Don't even think about syntax right now. Just problem solving. Here we went to Home Depot. Sitting in front of you is the tools that we've introduced so far. Just problem solving. Okay, I'm not going to ask you to write loops or anything. You know, you could say, oh, I want to do something so many times, but don't worry about the Java code. Let's just think about how we'd solve this problem based on the tools that we have. All right, so in real life, what might we do? If I said I want to pick a random letter from the alphabet, somehow, you know, I'll close the laptop. We're going to do that in here in real life. How would we pull that off? What would your suggestion be to pick a random letter from the alphabet? Oh, we need the letters of the alphabet, right? Okay, so maybe we get out little pieces of paper. We write A, then B, then C. Okay, so we have all the letters of the alphabet written on little tiny pieces of paper. And then maybe we throw them into a hat. Shake it up. and then somebody reaches in and pulls out a letter. That's what we want, right? So the first thing we need to do is we need to write down all the letters of the alphabet. All right, let's do that. Did I get them all? A, B, C, D. Okay. So there's all the letters in my alphabet. How many letters are there? Letters dot length number of letters, exactly. Okay, letters dot length number of letters. All right. So 52 is fine. So what are the legal positions in this string? 0 to 51. So in order to randomly pick one of those guys, I need to generate a number between 0 and 51. Okay. So here, give me a random number generator again. Okay. How do I pick a number? So maybe we call this guy pause. I want pause to be equal to some number between 0 and 51. How do I do that one? Anybody but him? Okay, very close. I'll write what you said, and most of what you said is right. You said this. I need a number between 0 and 51 inclusive. Well, plus 1's not going to do it either because that'll give me 1 to 51. This guy needs to be a 52 because it's non-inclusive. So r.nextInt 52 will give me a number between 0, including 0, and 51, including 51. So 1 minus whatever you put in here. Make sense? So that's what this guy gives me. This guy, as I have it written right here, will give me a number between 0 and 51. That's what he produces. When you had a 51 in here, he would have produced a number between 0 and 50. So 1 short. We would have never picked the uppercase Z as our random number. All right, so next then gives us a number between 0 and whatever we put in here minus 1. That's the range of values it gives us. Oh, I don't know. Well, but this is bucket 0.
Oh, right.
Yep. So I'm going to say letters.length in here. And that will give me the correct length. That should be 52, but it's letters.length. So this is going to give me a position between 0 and letters.length minus 1. And then I'll just return letters.char@pause. There's my random character from the alphabet. Okay, now I need length number of random characters from the alphabet. So I want to ask, because remember length is my number between 3 and 8. Okay? So I want length number, random letters from the alphabet. So I'm going to do this length times. So for int I is equal to 0, I is less than length, I plus plus. Each time through, I want to call my get random letter. Driver.get random letter. Now, for right now, let's just print this out to make sure it's doing what we think it should be doing. All right, and let's get rid of this stuff up here. And I'll go ahead and we're going to call driver genString. And what will genString do? It's going to generate a number between 3 and 8, and then it's going to print out that number of random letters. Right? So if I run this a couple different times, we should get different length lists of random letters. All right, so let's prove to ourselves that that's what this guy is doing. So there's our first string. This is 4 random letters. We haven't built it into a string yet, but it looks random enough. A little bit longer, still random. All right, looks like it's doing what it's supposed to be doing. Okay, now we ultimately want to have those guys in a string format. So how do I do that? Declare a string. What kind of string? A string kind of string? What's a good string for building? I want to build a new string, right? All right, so in here, my ultimate answer is going to be some string. What string should this be?
String with dynamic size, because we actually know the size. It's the size of the head. So new string of head size.
All right, yeah, that's all made up stuff. A, I haven't introduced that. B, that's not right anyways. Okay, so we can't, strings are dynamic by definition in Java. All right, so we don't define a string of a fixed size. We define arrays of fixed sizes. So again, let's go back to real life. Okay, I'm going to do some building, right? We know we're building a string here. If you're going to build a house, what's a good starting point to build a house on? Do we build it on top of another house? You want a nice flat, empty plot of land, right? Nice open space. That's a good place to build a house. You don't go and find somebody else's house and build it on top of that, right? So let's start with the empty string. The string that is a string but has nothing in it. A nice empty space. Okay? And now we're going to use this guy to build up our new string using concatenation. So each time through this loop, rather than printing out my random letter, I'll say answer is equal to answer concatenated with whatever my next random letter is. And then just to prove it worked, after that loop is done, we'll go ahead and say system.out.println answer. So this is outside the loop. We're still not returning it yet because I still have that guy set as void. But this should show us our random strings in a string rather than vertically just printing out individual characters. So there's a string, there's a string. It's always fun to do this and see if you accidentally generate profanity. All right, we're getting random strings. Okay, so finally, let's go ahead and let's have this dude, instead of printing out that string, let's have it return our answer, which means this guy is going to return a string. Okay? And then up here, what we want to do is we want to create an array.
Sorry, quick question.
Sure, go ahead.
I know you've already answered this before. Returning just stores it, right?
Well, it doesn't store it yet. Returning it right now means that this guy will boil down to the value that we return. I still have to choose to put it somewhere. But what we're doing now is we are, instead of printing it like we were a few minutes ago, now this program is going to have no output right now. We won't see anything on the screen. Because right now I'm calling genString. GenString is generating the string, returning the string it generated, and I'm doing nothing with it. I'm not putting it anywhere. I'm not printing it. I'm not doing anything with that value. So if I run this, all the logic happened. A string was generated, but I didn't do anything with it. Well, it does. Our program actually ended here. When we returned here, that means that genString ended. This method call finished, which then returned control in the program back to where we originally called it. All right, so when we're sitting here, our program begins and ends with main. So right now our whole program says do this one thing. So we step up there, we say, genString, do your stuff. genString goes to work, whatever, and when they're done, they say, okay, I'm done. They returned. something like that. But now we're back here. Okay, so it's almost like playing catch. Okay, so I tell him to generate the string. When he's done, he throws the string back to me and I catch it. Okay, but in this case, I just watch it sail by. So I'm not actually putting it anywhere. I can put it inside of a string if I want to there. I'm still never printing it, but I'm storing it. So at least I caught the pitch, right? He threw it, I caught my random string. Then I can come down here and I can print that out if I want. Proving that we now caught it, and then I displayed like, hey, I got it, right? All right, so there's our one string. If I run this multiple times, you'll see we get different length strings. Okay. But now, to kind of match up what we did before, I kind of want to store maybe 20 strings, right? Something like that, a whole bunch of strings. What kind of thing do we know how to create that can hold a whole bunch of something? An array. And arrays can hold all sorts of different same type values, right? So we want to create a string array. Up to this point, we've created integer arrays. So I'm going to say string array, we'll call it AR again, equals new string array, capable of holding 20 of those dudes. Then I'll go ahead and I'll create a loop for int I is less than, how many buckets are in AR? AR.length number of buckets. I plus plus, because you don't want to write 20 here, because if you write 20 here and then somebody changes this to 30, all of a sudden you got to change more code than just that guy up there, right? And then what are we going to do? We're going to say AR at bucket I gets the value of whatever's returned by this particular call to driver.genString. So this will call driver.genString, in this case, 20 times. It'll call it AR.length number of times. Each time it calls it, this guy will generate a random string, and we will store it at bucket I inside of AR. All right, so now I'm storing a whole bunch of random strings, but I kind of like proof that I got those random strings. So we need to be able to print out that array. Down here, left over from last time, we have our print array. This guy actually only knows how to print out integer arrays. So we can change this to now know how to print out string arrays. We actually don't have to change anything else. He just happens to take in a string array now. The rest of this logic's the same. How many strings are in there? Well, there's bob.length number of strings. Go through each one and print out the value you found there, which is the string. So last thing we'll do here is we'll go ahead and we'll say driver.printArray, and we'll go ahead and pass it AR. And we hope we find, in this case, 20 random strings. So there's our 20 random strings. Did we get any words? Yeah, that's not a real word. We'll run it again. One time I wrote something along similar to this that it did generate a four-letter word. Very specific one. It jumped out to the class real quick. Hey, it wasn't my fault. It was fate. It was the random number generator said this is what's going to happen. All right. So now I got a bunch of strings. Now it'd be nice if our merge sort worked on sorting. Sure, go ahead.
The string, declaring use position of 20 strings is 20 of length 6 to 8.
This is 20. I'm creating 20 containers. Each of those containers can hold any length string. Okay, so this is like going to Target and buying because strings, contrary to what he was saying, strings are dynamic. We can keep adding length to a string. Okay, so when we create a string can be size 0. It can be size of int, which is 2 billion. number of buckets in a string. I believe that's the actual limitation for it, but let's call that 94.5% positive there. Okay, but they're definitely dynamic. So really what this guy's going to hold is a bunch of pointers. Now, remind me, have we done this in here? Have we done those things? Where I was talking about the string literals. I probably pointed somewhere down here. All right, so remember those dealt with memory addresses, right? So when we have a hard-coded string literal, we get a memory address down here. Otherwise, when we create a new string, we get a memory address up there. Down here, because we're building up our strings, okay, we're building up our strings in here, it's going to be a new memory address. So even if we happen to randomly generate two identical looking strings, using the double equal sign on those guys will not fly. Okay, because they will not be the same memory address. Make sense? Okay, so really what we're creating here, so along those lines, is this is creating an array called AR capable of holding 20 memory addresses. Each one of those memory addresses will point to a string, however long that string is, but they'll live all throughout memory.
Right, but those are the strings created by gen string.
Not yet. Here, they're not. Here, it's like I went to Target, bought 20 buckets. I haven't put crap in them yet. Now, I put stuff in them. This is when I'm actually generating a string and then tossing it in one of my 20 buckets. Okay, so up here, I just have 20 empty buckets. Nothing's in there. Ready to start packing stuff is what it is. All right, make sense? All right, so there's our 20 random strings. Now we'd like to modify our merge sort to work on strings. But we have a problem. Our merge sort's doing a whole lot of stuff like less than, right? We go down to our merge sort here. Specifically, the merge step of our merge sort. Well, yeah, like right here. I'm saying, is this value smaller than this value? Well, if I'm changing my merge sort now to work on string arrays rather than int arrays, so let's go up here and we'll change this guy to be a string array instead of a int array. This says we can't convert. Oh, that's because I need to make this guy a string array. So my temp array also needs to be capable of holding strings, not ints. Okay. So if we go through this, are all these guys okay? Keeping track of the beginning, the ends, the middle, all that stuff. That's just positions, right? That doesn't change whether I'm dealing with strings or dealing with integers. So we're good there. My calls to merge sort then are also okay. Our merge step down here, my temporary storage location, it's got to be built for holding strings instead of ints, but we've updated that, so that's okay. We're still going to go through temp.length number of times. Fine. These first couple of if statements, these guys are still okay because we're not actually comparing values. We're just saying, hey, are we already off the end of the left half? If we are, steal the right half, whatever the value is at the right half. Are we already off the end of the right half? If so, the winner was the left half. Take that value. Otherwise, right here, we need to figure out how do we ask this question in terms of strings. Make sense? How do I compare one string to another string?
Comparing each individual character.
We're going to compare each individual character. Okay, so what we're going to do here is we're going to end up writing a method. Let's start the method here, then we'll take a quick break. So we'll take a couple of quicker breaks today. So we'll start the method. So we're going to say static Boolean well, let's just call it is less than. So this will take in a string A and a string B. And this guy should return true if A should come before B and false otherwise. Effectively, we're writing the less than operator for strings. That makes sense? How would that work? So if I have two strings, for example, if I have cat and I have dog, which comes first? Cat. How do you know? Because of the C, right? So we start walking the first string and the second string, and we ask ourselves, are these the same letter? If they're not, which letter comes first? Does that make sense? So we can make the decision that way. Which comes first there? Cat, the shorter one. Shorter one comes first. All right, so we have to write the code that actually does this comparison. Make sense? Do we go through the smaller number of, do we figure out which string is smaller? Is that the one we circle through? Okay, and if we're still kicking, we're okay. So how do we determine which of the two strings is smaller? All right, so what we're really looking for is the minimum value between the length of A and the length of B, because that's the number of characters we can directly compare, correct? So why don't we write a function, static int get min int A int B. So this guy, his only job is to return the minimum value of A and B. We just ask a quick question. If A is less than B, return A. Else, return B. Pretty easy one to write. So that's get min. So now we can say something like int chars to check is equal to driver.getMin. We're going to pass this guy two integers, a.length, b.length. And what it's going to give us is the number of characters that we can compare to each other for these two strings. That makes sense? All right, so now I'm going to go through and I'm going to check.
Sorry, I'm still trying to understand. Int chars to check just holds the answer to what we're doing.
Yep. Chars to check holds the result of that whole call. And this guy's ultimately calling get min. The result of get min is an int, that kind of dude. So ultimately what get min is going to do is it's going to return the smaller number between that number and that number. And that smaller number is going to, this whole thing is going to boil down to just a single int. And we're going to store that int right here. Okay, so if I had cat and cats, it's going to boil down to 3. Because 3 is smaller than 4. 3 is the number of characters that I'm able to check in both of those strings. All right. So now we'd write a little loop. For int I is equal to 0, I is less than chars to check I plus plus So this is going to take I on a voyage through all the characters in those strings. And then I need to do some comparisons on those characters. All right, so let's pause it right here. Let's take 5 minutes. Okay, so grab a drink, run to the restroom, whatever. So we'll come back at 7:16 and we'll keep writing this guy. All right.